So this is the problem number 6 from chapter 5. So we have a particle in a centrifuge, which is actually at a distance of 7 centimeter from the axis of rotation of the centrifuge. So that means R is 7 centimeter, which is equal to 0.07 meter. And the acceleration of that particle at that distance is 125,000 Gs. So based on the information here, we want to find out the velocity of that particle in terms of revolution per minute. Okay, so first thing here, let's convert A, which is in terms of G, to meter per second square. To do that, I'm going to have to multiply this value, which is 125,000, to the value of G, which is 9.8 meter per second square. Okay, so 125,000 times 9.8 meters per second square. So this is going to give me 1.225 times 10 to the 6 meter per second square. Okay, so this is the acceleration of that particle rotating in the centrifuge. So next, we want to find out the velocity from the relation between the centrifugal acceleration and the linear velocity. So the relation between the centripetal acceleration and the velocity is given by AR equals, let me erase this. So AR equals V squared over R. Okay, so from here we get the velocity, linear velocity, to be AR times R. So we have the value of AR in terms of meter per second square, and the radius is 7 centimeter, which is 0.07 meter. If we plug in that value, we get the linear velocity to be 292.83. 292.83 meter per second. All right. So we have the velocity in terms of meter per second. So we need to convert this to revolution per minute. Okay. So the first thing that we need to do here is write the velocity, linear velocity, in terms of angular velocity. Okay. So linear velocity, V. So we know that V has to be equal to angular velocity times radius. So angular velocity, this guy here, is twice pi f. Okay. And the next one is radius. So from here, we can find angular frequency, F, to be equal to V over twice pi R. All right. So we know the linear velocity, and then divide by twice pi times the radius. This should give me the value, the frequency, to be 665.79 revolutions per second. Okay. Let me rewrite this one. So 665.79 revolutions per second. but we want to find this value in terms of revolutions per minute, right? So that means we should convert that to revolution per minute. So first, F equals 665.79 revolutions per second, and 1 minute is going to be 60 seconds. So 60 seconds over 1 minute. So from here, you will get the frequency of that particle in the centrifuge to be 3.99 times 10 to the 4 revolutions per minute.